Hi, everyone. Welcome to Scaling Microservices Apps, Migration to Redis Enterprise on Google Cloud. So today we're going to be demoing a fully functioning microservices application on Google Cloud using open source Redis and show you how to migrate the data to Redis Enterprise with minimal downtime. So as part of the demo and the presentation today, you're going to get documentation, you're going to get Terraform code, you're also going to get a $1,000 coupon to get started with Redis Enterprise on Google Marketplace. So stick around for all of that, but let's kick off. I'm going to start by introducing the guides for the session. First of all, we've got Gilbert Lau from Redis, and we also have Cody Hill from Google Cloud joining us.
Hey, nice to meet you. Yeah, so my name's Cody Hill, and I'm a solutions consultant for Google Cloud. I work in the cloud partner engineering team, mainly focusing on cloud native technologies such as Kubernetes, Cloud Run, Cloud Functions, things like that. Gilbert?
Hi, my name is Gilbert Lau. I'm a partner solution architect for Google Cloud at Redis. My main role is to develop technical alliance partnership with Google Cloud. I've been working with different parts with Google Cloud to proliferate the Redis Enterprise in both brownfield and greenfield opportunities. We jointly build integrated solutions on Google Cloud to showcase the possibilities of Redis Enterprise for real-time use cases in different industry verticals, as well as horizontal use cases.
All right, well, with that, I'm going to leave it to you folks to kick us off, and we'll see you for Q&A.
Thanks, Steve.
Thank you. So the agenda for today is first, we will talk about who is Redis. Then we will talk about what is Kubernetes and GKE. Then we will describe and talk a little bit about the demo environment overview. Then we will dive into a live demo to migrate from OSS, open source Redis, to Redis Enterprise. Then we will close it with takeaways and next steps. So who's Redis? Redis is the home of open source Redis, the world's most popular in-memory database and commercial provider of Redis Enterprise, which simplifies the development of highly performant, reliable, and seamlessly scalable real-time applications, including any e-commerce, mobile, social, personalization, fraud detection, and many others. Redis is the most loved NoSQL database in Stack Overflow developer survey for many years in a row. It is a trusted database solution with over 8,900 paying enterprise customers across all industries. It is extremely popular in open source community. It has over 6 million daily downloads on Docker. It has over 162 client libraries in 80 different languages. The momentum is unstoppable as real-time becomes the standard of engagement. So this is the journey map for Redis adoption. It is normally started with open source Redis for simple cache use case, such as application caching or session management. It is a self-managed consumption model where customers are required to manage the lifecycle of the Redis deployments. Growth always happens. This makes customers to consider an outsourcing consumption model as they need to focus on the daily business need rather than managing Redis. There are many fully managed services available on Google Cloud. Of course, memory store would be a good fit for next step for shifting from self-managed model to fully managed Redis Enterprise solutions to obtain 3 nines, SLAs, and other enterprise features offered by memory store such as data persistence and high availability. As customers' business continue to grow, they are likely to reach the limit of what memory store can do. it is a logical next step to upgrade to fully managed Redis Enterprise in Google Cloud Marketplace. The customer will be able to leverage the existing Google Cloud commits and enjoy the unified billing. On top of that, the customer will be able to receive 4 nines to begin with and up to 5 nines if Redis Enterprise Active is employed. It supports multi-cloud and hybrid cloud deployment models. Developers can find Redis Enterprise modules handy when developing advanced use cases such as enterprise search, vector similarity search, and others. In summary, there are 3 main flavors to deploy Redis on Google Cloud. At the far left, it is the self-managed model best suited for non-business critical workloads. In the middle, it is the cloud-only memory store based on open source Redis with 3 nines availability. But it has a 300 gigabyte dataset limit. It remains the best solutions for application caching and session management and departmental use cases. However, it is not ideal for all kinds of use cases. At the far right is the Redis Enterprise in Google Cloud Marketplace. It is a fully managed Redis solutions with the capability to deploy in multi-cloud and hybrid cloud architectures. We started with 4 nines availability and get up to 5 nines SLA through active Redis Enterprise clusters, serving millions of operations per second under 1 millisecond latency. It supports up to 25 terabyte memory and 100 terabyte with Redis on flash. Throughput reached at the rate of 150 gigabyte per second. It is by far the most scalable Redis solutions on Google Cloud. So Redis has been used in horizontal use cases across different industries. Let's talk about now how Redis shines in retail industry with its performance, scalability, and availability. Auto Beauty was founded 3 decades ago. Its mission is to use the power of beauty to bring out the possibility within every person. They are a strong believer of combining beauty and retail. So Auto Beauty is running a digital-first initiative with a longer-term plan to move the IT infrastructure completely from on-prem to the cloud. During COVID-19, customers were not allowed to come into their store. Curbside pickup became a top priority project to continue delivering beauty products to their customer in a safe environment. So this was an entirely new function. They need to build the whole new application on GCP from scratch. A real-time inventory system is critical to maintain the consistent inventory at every single store. It became a data challenge. So at Auto Beauty, they have been using open source Redis on-prem for years, meaning Redis is no stranger to them. But for real-time inventory, they need a fast, geographically distributed database, which can provide access to all the same inventory information in real time, over 1,300 stores across the United States. So let's talk about how and why Auto Beauty chose Redis Enterprise. So Redis Enterprise active geo-replication available through GCP Marketplace provide the data layer for hosting the real-time inventory. It provides 5 nines SLA service availability to keep the inventory not only in real time, but also always on. Redis Enterprise as a fully managed database as a service accelerated the development life cycles, as well as shortened the time to market for this new curbside pickup function. Being able to run Redis Enterprise in a hybrid cloud environment was a mandatory requirement for maintaining consistent and real-time inventory informations with on-prem and at the stores. There have been many projects coming after the curbside pickup department. Auto Beauty found our GCP Marketplace solution extremely handy in the sense that getting a new Redis Enterprise database instance up and running for a new project is simply just a few mouse clicks. All the day-to-day maintenance of the underlying database clusters would be handled by Redis. So let's have Cody to talk about what is Kubernetes and GKE.
Yeah, thanks, Gilbert. So yeah, let's talk a little bit about what is Kubernetes. So Kubernetes is the second largest open source project in the world, second only to Linux itself, right? And essentially, Kubernetes is a system for running and coordinating containerized applications. These applications are deployed across a cluster of machines, right? So they scale horizontally. And as the Kubernetes user, you define how the application should run in a declarative manner. So you say, I want it to look like X, and then Kubernetes will make that happen. You also define how the application should interact with other applications from a networking standpoint. So inside the cluster is both, as well as outside the cluster. Next slide. So that's what Kubernetes is, but what is GKE? So I like to use this quote from Kelsey Hightower. So if you don't know who Kelsey Hightower is, he's a rock star in the open source community. And he essentially finds very creative ways to demonstrate open source software and then demonstrate them. So I'm going to do my best Kelsey Hightower impression later for the demo. But the way he sums up what GKE is essentially it's the cheat code for Kubernetes, right? So Google manages all of the heavy lifting and all the hard stuff, and you get to just consume and use Kubernetes. Right, so I think it's a pretty good analogy there from Kelsey. Next slide. So essentially, in a nutshell, what GKE does for you is it gives you a 100% fully managed control plane for Kubernetes. All you have to do is worry about your worker nodes. You don't have to maintain the control plane nodes whatsoever. And we give you a very tightly coupled operating system with the GKE engine that are co-engineered together to make sure that they work very well. We also then have very deep integrations with all of the other GCP services, from the networking layer to monitoring, CI/CD, Cloud Run. All of the other tools and things that you might need to use to build an application is very tightly coupled. And we have the fastest Kubernetes engine in the industry, right? So spinning up new clusters, expanding that cluster, adding nodes is super fast with GKE. Next slide.
Now we will discuss about our demo environment overview. The online boutique we are showing today is a cloud-first microservices demo application. The online boutique consists of an 11-tier microservices application. The application is a web-based e-commerce application where users can browse items, add them to the cart, and purchase them. So Google used this application to demonstrate the use of technology like Kubernetes, GKE, Istio, Stackdriver, gRPC. This application works on any Kubernetes clusters, as well as Google Kubernetes engine. It is easy to deploy with little to no configuration. To be specific, in this webinar, we want to highlight that the shopping cart is implemented using Redis in-memory database for speed and performance. It is the world's fastest database for extremely low latency and real-time use cases. We'll share the demo workflow on the next slide. The About architecture depicts a microservices architecture for retail e-commerce application running on Google Cloud. It consists of a plethora of microservices assembling the e-commerce application designed for scalability and performance. Not only it can support ever-growing load on the system, but also can it be scaled down to minimize costs for seasonal shopping pattern in retail. The microservices are running on Google Kubernetes Engine cluster, the industry most trusted managed Kubernetes platform. The fully managed Redis Enterprise database solution offered through GCP Marketplace provides unparalleled scalability and performance to the shopping cart in the backend with enterprise-grade security and production support. It makes the entire architecture to become fully managed. This warrants more time for retailers to focus on their core business rather than operating and managing the underlying application infrastructure.
Great. Yeah, so I wanted to talk a little bit about some of the other components that you're going to be seeing inside of the live demo, just so you're kind of aware of all of the moving parts. So from left to right, we have the Nginx Ingress controller. And so what an Ingress controller does is that it handles layer 7 routing of your applications to the service inside, right? So think of it as a layer 7 load balancer inside of your Kubernetes cluster. So it'll allow HTTP and HTTPS communication. And you create that with an ingress rule. And so we'll be looking at an ingress rule a little bit later. And in that ingress rule, you can also define the name of your website, right, with a domain. So there's another product called external DNS that we have in this cluster. These are all open source, by the way. And the external DNS will integrate with your DNS provider. In this case, in this demo, we're using Google DNS or Cloud DNS by Google. And just by creating that simple ingress rule from the Nginx controller, it will automatically reach out to your whoever manages your DNS, whether that's Google or GoDaddy or what have you, and create those records automatically for you. So you don't have to do 2 steps, right? It's monitoring what's in the Kubernetes cluster and creates that DNS record for you. And the other thing that rule can do is if you tag it to create an SSL certificate for you, it can integrate with Cert Manager and create an SSL certificate request on the fly. So Cert Manager has the ability to validate with quite a few different options to say it could do a DNS lookup, it could do an HTTP endpoint check, or a few other options to say, yes, you do own that domain and you're allowed to get a certificate. And the certificate authority that it works with is Let's Encrypt. So Let's Encrypt is an open source, a nonprofit that basically their whole goal is to encrypt the internet, right? Don't allow any website to go unprotected. And so you can get free SSL certificates through Let's Encrypt, and Cert Manager is just a way to help manage those. So the Let's Encrypt certificate that's issued to you is short-lived. I think it's 30 to 90 days. And then you need to renew that certificate quite frequently. So having something like Cert Manager handle that renewal process and a certificate rotation for you is great. So we have all 4 of these components inside of this demo environment as well, along with all of the microservices that Gilbert explained previously. Gilbert? Oh, it's demo time. So live demo, this is the fun part. So we're going to be migrating the open source database from this environment over to the Redis Enterprise environment. So we have a GitHub repo here. We'll be sharing a QR code and a link. So don't think you have to grab it right now. But all of this code for this demo is available here. So you can go ahead and scroll through here and see exactly how we built this environment and try it out yourself. So this is the online boutique application. Okay. So what we're going to do is, grab some sunglasses and add those to cart and place our order. And now I'm gonna get some sunglasses shipped over to me, right? So a nice front-end website. It's pretty good. You can see that in the menu bar, we do have a domain here, www.redis-gcp.com, and we have a valid certificate. So the certificate was requested by Cert Manager and was issued by Let's Encrypt, like we talked about before. All of this is running on top of a GKE cluster, right? So inside of Google Cloud, we have our GKE-www cluster, because that is hosting the www.redisgcp.com. The integration here is also with Cloud DNS, as I mentioned. So all of these rules that you see inside of the Redis GCP com domain are being managed by the external DNS provider inside of the Kubernetes cluster. So you can see this is our public IP address for that Kubernetes load balancer. And we have a record that got created on the fly, as well as a few other text records that kind of help external DNS keep track of its DNS entries. As Gilbert mentioned before, we are using the Google Cloud Marketplace for Redis Enterprise. So we're provisioning that directly through here. And once you do the provisioning, you have the manage the provider, and that pops you out over to the Redis Labs website so that you can manage your environment. So we have a subscription here for this environment called GKE www. And then we have a database inside of this subscription, and that is the online boutique cart database. So this was all created on the fly with that Terraform. And so let's go ahead and jump into the live environment and poke around a little bit, right? So I'm going to do a kubectl get pods, and these are all of those microservices that you could see were created previously. So we have the front end for the website. Here we have the cart service that handles putting things into the cart, and that interacts with the Redis cart that we have down here. Okay, so essentially that's how this this works. Is you look at the front end, that's what's being served, and when you add this to the cart, it does a insert into that Redis database. Let's go ahead and add a few things to our cart. We'll get some sunglasses. I need some salt and pepper shakers. And how about a nice coffee mug here? So great. So we have a nice shopping cart with 3 things in here. And those all got added into this open source Redis cart container here. So that's great. And then let's just go ahead and look at a few other things. So we could do a kubectl get namespaces just to kind of look at what's here. So you can see we have our Nginx Ingress controller that I talked about before. We have our external DNS namespace that's managing DNS for the cluster. And we have our Cert Manager deployment as well that's managing getting those certs and getting them signed for us. So if we do a kubectl get ingress for the front end, and output that to YAML so we can kind of see what that looks like, it's actually a very simple spec that we have here. This is the only thing you have to configure. And essentially, what we're doing is saying, hey, this is the DNS name that I want. And I want a TLS secret created for me on the fly. And then you have to add an annotation up at the top that says, I want to use Cert Manager to get my certificate, right? So very minimal amount of definition here, and it automatically creates the DNS record and automatically gets that certificate for you. So pretty nice. And then let's go ahead and look at the deployment that we're going to be messing with today. So kubectl get get deploy cart service. So this is the cart service that we're going to be playing with, and we're going to be looking at some specific variables and updating those here. So right now, this cart service is pointing to a local endpoint. It's our Redis cart at 6379. That's the port we're connected to, and we need to migrate that data over to the enterprise version of Redis. So let's go ahead and do that. The first thing we have to do is collect some information. So we have our terraform outputs here, and this kind of shows the Redis endpoint that we want to use. It also shows it has the password. It's sensitive, so we're not going to print that to screen, and a few other bits of information here. So I'm going to start storing these into a variable to use. So we're going to save that to the Redis destination, the Redis destination password, and the Redis endpoint string is going to combine both of those into a nice Redis endpoint string here. So that's great. The next thing we need to do is create a secret that has this built into it. Okay, so I'm going to go ahead and paste this to screen before I press enter. So we're creating a secret real quick from some string data. We're saying, hey, this is the source of where all of the data is stored, right? You can see that's the same source up here. And we want to store the destination and the password to connect to the Redis Enterprise environment. So let's go ahead and create that secret. So we have that secret set up here. So that's great. The next thing we want to do is deploy a Kubernetes job to do that migration. So this is stored in that same GitHub repo that we showed you. It's a very simple job. And essentially, oh, I already had this in the environment. Let me delete this real quick. kubectl, delete job. This guy. Okay, so I already did this previously. Let me go ahead and run that again. So we're going to run this job, and what it's going to do is it's actually going to read the data from the source Redis database and copy that over to the destination database, which is Redis Enterprise, and it's using this secret to know what to connect to and what to connect to and what to send it to, right? So we'll go ahead and do that. We'll do a kubectl get pods. And you can see that this job is running right now. It's been running for 3 seconds. It takes about 15 seconds or so for this thing to run. We can also do a get job and look at that. Oh, and you can see it's completed, right? So took about 9 seconds. If we get pods again, you can now see that this job is completed and we're in good shape. So now we've synchronized all of the data from this Redis cart pod to the Redis Enterprise environment, okay? So the next thing that we want to do is we want to update that cart service. So we're going to be patching that cart service with this patch command. So we're basically telling it to patch the deployment, grab the container that's named server, and update its environment variable Redis address with the value of our Redis endpoint. So now, when we rerun that previous command, here, we can see we've now replaced this value with a much longer value for the public Redis Enterprise environment. I'll make sure I tear this down since you now have the password to it, but it is secured because it can only be communicated to from within inside of my VPC. So that's in good shape. We've now moved that over. And what we want to do is make sure that our environment still works, right? So if I come to the online boutique over here, I still have all of my data in the cart, right? So it remembered me, everything's good. I can hold shift and do a refresh. And this is all being stored in that Redis database, what's in my cart, and it works. I can go ahead and place my order. And now my orders are now stored in that Redis database and life is happy. So that's great. So that's still working. So now that we know that that's working, let's go ahead and make sure there's no shenanigans going on and actually delete that Redis cart deployment. So we'll do a kubectl delete deploy. and get rid of this Redis cart right here. It's actually called just Redis cart. So we can do a get pods. And you can see that pod is now gone. And we still have access to this environment. Life is good. Everything is happy. I can grab another pair of sunglasses and place order. So that's great. Basically, that is the live demo that we wanted to demonstrate today. Is that you could very easily start out with Redis Enterprise, get your application up and running, and when it's time to move from that open source version to the enterprise version, you can use that that job that's in this this GitHub repo to do that migration very quickly. And we experienced last time I did this and timed it, it was about a total of 30 seconds of downtime or so for that pod to be killed and recreated with the new Redis endpoint. So there you go. So if we can move back to the slides with Gilbert.
Thank you, Cody, for the very nice, super nice demo. Let's summarize what we have talked about today and share with you what you can try to do next. In our webinar today, we use Terraform automation to deploy the demo end-to-end, then migrate the shopping cart data to Redis Enterprise database using pre-built Kubernetes job. Then we configure valid DNS and SSL certificate for the application. It was a seamless and friction-free process to switch over from open source Redis to Redis Enterprise. You can follow the QR code or the link here to claim your $1,000 coupon credits to try out Redis Enterprise in your Google Cloud environment. The shortened URL and the QR code here will bring you right to our demo repo to get yourself into the driver's seat to experience the speed and scalability of our combined solution from Redis Enterprise and Google Cloud.
Awesome demo, folks. I love a demo. I love it when a demo works out. So well done. So we got a couple of questions, and I'm going to start with you, Gilbert. In the demo, you used Redis to store the shopping cart information, but how is that persisted? Like, is there any persistence assigned to that information? So the in-memory aspect isn't, a risk if you sort of lose connection or you lose the operation of that data store.
Yes, we do. We did save, the shopping cart information onto disk. The Redis Enterprise offers data persistence through a panel file and RDB snapshot. The RDB snapshot offers a point-in-time snapshot of your data sets, while the AOF, the appended file, could log every single write operation received by the server.
So the in the demo, you showed off Terraform provider. Now, is that Terraform provider fully supported by Redis?
Yes, we just released our version 1 2 months ago. It is currently in version 1.01, and the demo we use is the version 1.01.
Awesome. Thanks. One for you, Cody. I noticed that there was a domain as a part of this. There's SSL. Do we need a domain to run this demo?
Yeah, it's a good question. So in order to get a valid SSL certificate, you do need a valid DNS domain that you own. It doesn't have to be a Google Cloud domain. It can be from your GoDaddy account, and Cert Manager has, external DNS has plugins to manage that through almost every DNS provider in the world, whether it's Cloudflare or the big 3 public clouds or GoDaddy. So any valid DNS will work. If you don't have one, you can use Google domains and purchase one right through your Google Cloud account.
Cool. Yeah, I've done that in the past. It's super easy. I love how those are connected together. Gilbert, one last one. How do we learn more about Redis Enterprise, particularly as it connects to Google Cloud?
You can go to this webpage on redis.com, redis.com/cloud-partners/Google. It hosts use cases, white papers, and discuss more of the benefits of running Redis Enterprise on Google Cloud. We are always here to answer additional questions.
Awesome. So the partner section of Redis Enterprise. Okay. Well, with that, I think it's time for us to go. I want to thank you, Gilbert and Cody, for joining us. Thanks to the audience for joining us. And to everybody, you can expect an email with the recording. And in the meantime, check out redis.com for more information.
Awesome. Thank you very much, Gilbert, Steve. Appreciate it. Thanks for the audience.
Thank you, everyone.
Thanks, folks.